So let's talk about the hidden battlefield of our digital world, API security. These are the invisible wires that power pretty much everything we do online, but as we're about to see, they're also a massive target. I want to start with a number that should really make you sit up and pay attention, 94%. Yeah, according to a recent report, that's how many companies had a security incident in their production APIs in just the last year. That's not a small fraction. That's basically everyone. It tells you that attackers aren't just poking around APIs, they're actively and successfully getting in. So, what are these APIs that are under so much fire? Well, the easiest way to think about them is like digital waiters. When you're using an app, it needs to get data or tell a server to do something. The API is that messenger that takes your request, runs to the kitchen, the backend server, and brings back exactly what you asked for. They are the absolute backbone of modern software. But here's the thing. Because they're so critical, these connectors have also become a hacker's playground. Why? Because they're a direct pipeline to the stuff that really matters. Okay, so let's get inside an attacker's head for a second. First off, APIs are a direct line to the crown jewels, all that sensitive data. Second, they can be used to trigger really important actions, things like making payments or changing orders. Third, and this is a big one, attackers love hunting for those forgotten or shadow APIs that nobody documented and nobody's watching. And finally, since there's no user interface, attackers can just hammer them with automated scripts at lightning speed. And this isn't some abstract theoretical risk. A single flaw in just one API can be a straight shot to exposing your most sensitive data. We're talking about a direct line from a tiny coding mistake to a massive data breach. So how do the good guys fight back? Well, they don't just go in blind and start looking for problems. The pros use a structured approach, a formal security playbook that's designed to find and fix these API vulnerabilities. And the heart of that playbook is something called API pen testing, short for penetration testing. It's this structured, repeatable process where security experts basically simulate a real attack. And I have to stress, this is not about just clicking run on some automated tool. It's a comprehensive run book that a person, a human expert, follows to map out and test for every possible threat. It ensures nothing gets missed. Any professional pen test is really built on 3 key documents. First up, the API inventory. That's your map of the entire attack surface. I mean, you can't protect what you don't even know you have, right? Second is the threat model, which is where you map out all the potential ways an attacker could come at you. And third, you have the test matrix. This is the detailed game plan for how you're going to test every single endpoint against every single threat. This prep work is what makes it a professional engagement. Okay, so with that playbook in hand, it's time for the fun part, finding the crocs in the armor. This is where security testers put on their hacker hats and they actively try to break the API. Now, testers aren't just guessing here. They're guided by industry-standard lists of the most common mistakes. One of the most famous is the OWASP API Security Top 10. OWASP is this great nonprofit that's totally focused on improving software security, and their list basically gives testers an incredible checklist to kick off their investigation. And the number one vulnerability on that list is something called Broken Object Level Authorization, or just BOLA for short. What it really means is the API checks that you're allowed to do something, but it forgets to check if you're allowed to do it to the specific thing you're asking for. So, how simple is a BOLA attack? It can be ridiculously simple. Imagine an attacker logs in and asks for their own account info from, say, accounts/ID1. Then they just try something. They change that ID1 to ID2 in the request. If the API is vulnerable, it doesn't bother to check who's asking. It just says, oh, you want account number 2? Here you go, and hands over someone else's private data. All right, let's look at another really common one called mass assignment. This one happens when an API is, well, a little too trusting. It blindly accepts all the data a user sends without double checking if it's supposed to be there. Check this out. So an attacker is signing up for a new account. They send the normal stuff, username, password, but then they sneak in one extra field that's not on the form, something like admin:true. They're basically betting that the application will just save everything it receives, no questions asked. And if they're right, this is what happens. The APA framework just blindly takes that malicious admin field and maps it straight to the user account in the database. And just like that, the attacker has created a brand new user for themselves with full admin powers, all because the API was too trusting. Of course, the hunt doesn't stop there.
A full pen test is also looking for things like injection attacks, where you trick the API into running malicious code, or broken authentication, where you try to find ways to just sidestep the whole login process entirely. And this brings up a really crucial point: the difference between automated scanning and a manual pen test. Look, scanners are great. They're awesome for catching the low-hanging fruit and known bugs super fast. But a human expert, that's where you find the really clever stuff. The complex business logic flaws, like a pricing trick that takes 3 separate API calls to pull off, that a tool would just never ever understand.
So after all of this testing, you end up with a big report full of bugs. But the job isn't done. The goal isn't just about finding flaws. It's about what happens next, actually reducing your overall security risk. And this is such an important idea. A good pen test is not a contest to see who can find the most vulnerabilities. The real outcome is risk reduction. It's about giving a company a clear path to making their application fundamentally safer. So what does a truly successful pen test deliver? Well, it gives the engineering team findings they can actually reproduce. It explains the business impact, like why this bug matters. It gives them clear, actionable guidance to fix the root cause, not just patch a symptom. And then it involves retesting to make sure the fix actually worked. That's real value. When you boil it all down, it really comes to this. Our APIs are the digital doorways to our most critical data. They are the locks on our digital vaults. And that leaves us with one final, really important question: who's testing the locks?